Hey everyone, welcome to our Go West 2020 talk, a field report building a game engine for 300 DEFCON hackers to smash. I'm Alex Stockwell. I was the development lead for this project, and with me is my co-presenter Kevin.
Hi, my name is Kevin Tyers. I am, I guess, sort of the operating person for ICTF. I do some development, but I also work with our third partner, Blake, to develop game content for ICTF. So I do some of the technical work, I do some sales, some support stuff, so kind of a mix of everything. So again, on this picture here, you can see me on the left, and then in the middle, the guy with the dreadlocks is Blake. He's the one who actually started this whole crazy endeavor, and Alex and I have since joined on to help him out. And then on the far end, you see Alex. And at this point, we're all deflating some aliens after a very crazy party that we had to celebrate the success that was the game. So, when we set out to make this thing with ICTF, we thought about what conference do we want to run this at? And we decided we were going to do DEFCON. And we started running ICTF at DEFCON several years ago, like 2015 was our first year. And we had increasingly had more complex and more intricate games. And this sort of culminated in what we did at DEFCON 26. So if you're not familiar with DEFCON, it's a global hacker conference that's been around since the early 90s that's held in Las Vegas. The game that we actually played was on August 11th, 2018, but there were several months before that of setup. And we decided we were going to run it for about 6 to 7 hours. We wanted to give people a good amount of things to do throughout the day, but not eat up the entire day necessarily. In the end, we had over 300 players play our game, which is amazing. That's the biggest turnout we've ever had, and that's actually pretty big for a non-official DEF CON contest. It probably helped that we had a $10,000 grand prize for cash. And the team that won, right, received $10,000, which was really, really cool. And that was the courtesy of our sponsors. And it was great that people were able to win that much money. But the other thing that I loved about the way that we put the game together was that we awarded out literally hundreds of prizes and shirts and stickers, badges. I gave away a keyboard that I built because we wanted people to have a sense of accomplishment, even if they didn't win the game. We wanted to have the community really engaged with what we were doing. So, what was the idea behind ICTF? It was, we've always wanted to create these very immersive capture the flag events that feel realistic. And what we mean by realistic is it would be something like if you were an open source intelligence investigator and you had to really dig into an incident and an event. What would that feel like? What would that be like? What would it be like to interact with someone who was contracting you for your skills and abilities to investigate? The other thing that I really wanted to do was spend just a ton of money on our players in the event. We had some very generous sponsors, and we were able to throw a big party and get shirts and all this crazy stuff, which was really, really cool for us. And I'm a huge sci-fi nerd. You know, I love Philip K. Dick and Jeff Vandermeer and all these great authors. And it was kind of our turn to tell a really neat sci-fi story. In this case, an interactive story that players could be a part of. So we wanted to have an engaging story that had one-on-one interactions with a handler, right? Sort of this, smoking man X-Files idea of someone who's directing your actions from behind the scenes, which was really, really awesome. So when we were going through designing the experience, we asked ourselves, what would be enjoyable for players to experience, and what would also be valuable for them to experience? This really sort of amalgamated around the story that we wrote. So the high level of the story, without giving away too many details, is a hacker has broken into a company called Space Y. Definitely no affiliation to any real aerospace companies out there. The player and the player team that they were on, there could be teams of 1 to 3 people, was an analyst or a team working with an intelligence agency, which was left, to the player's imagination what three-letter agency that might be. And as they go through the game, they unlock information about a deeper conspiracy involving multiple types of aliens. They have to meet an arms dealer. And at the very end of it, they actually decide the fate of Earth and humanity itself. So we wanted to start out, very grounded, very simple, and then bring it into these very grandiose sci-fi ideas the players could be very tangibly involved with, which was really, really cool. The thing that made this game better than the other options to play, if I'm being completely honest, is the fact that we as a team spent an entire year seeding information on the internet. We didn't create some fake VPN environment that you had to log into. We really created domains. We really created social media accounts. We actually committed code to GitHub. You had to use Tor. We had real certificates on the certificate transparency log. Everything that we created was realistic and can be still found on the internet today for the most part. So this was a realistic seeding of synthetic data points to make this game very realistic for the players who are participating. The three areas of investigation that we focused on was OSINT, SIGINT, and HUMINT. So OSINT is open source intelligence, and this is the type of intelligence you can gain against a target or a person just using ostensibly public internet searches, right? Think searching someone's Facebook, using an API like Pipple, perhaps using a tool like Spiderfoot, that kind of information. Now, we also focused on signals intelligence, which is something I'm personally very passionate about. I come from a background of doing like networking and things like that. So we had a section where they had to analyze net flow and look at the traffic characteristics that the attacker and some of his friends were exhibiting and replicate that to get access to some later flags in the game. And then finally, what was terrifying but awesome because it worked so well was a human intelligence portion. That person on the right in the flower shirt, it's actually my little brother Trevor, and part of the game was to follow him to determine what hotel room this arms dealer was staying in. There's other human intelligence flags that we had, and it was exhilarating to be coordinating all the players to be following people and getting things from a coat check and going to the bar to meet some mysterious benefactor. It was absolutely incredible. So we wanted to tie all these things together to have an immersive, educational, and very enjoyable experience for the people who spent 6 hours playing the game with us. So when we were developing the game, we were very mindful of our timelines and constraints, and it was great having a drop dead date, right? We had to be done by August 11th. So we started seeding information, just random stuff we weren't sure if we were going to use, actually about October of 2017. And in February and March, we really put the story together, developed the narrative, developed the questions. And then in April, we got our sponsors, finalized our content. May, we moved on to getting registration and the game engine built. And then it was pretty much full steam ahead, getting the engine and all the constituent game pieces created for the actual game in August. And without giving the end of the talk away, it went pretty seamless and it was beautiful. And selecting Go as our technology platform of choice is a big reason why we were so successful. So with that, I'm going to kick it over to Alex to talk about the experience of building the game engine.
Yeah, so we knew with the ambitious vision that we had that there wasn't anything out there to our knowledge that would accomplish the kind of one-on-one interactions with players that we envisioned for our game. So we set out to build our own platform. And when thinking about what we would need, we knew that we'd have some basic requirements. We would need something that would support real-time interactions with hundreds of players. We wanted each player to basically experience their own story within our game at their own pacing and as they went along and things organically emerged to them in the story. So we wanted to be able to have an interaction per player, per team at the scale of potentially hundreds of those all at the same time to make this game vision a reality. We also knew that we're going to host this game at one of the most notorious hacker conferences in the world, DEFCON. So we knew that the game platform had to be secure, had to be resilient, had to be able to take a beating. And then beyond those kind of high-level requirements, we knew that we needed to take care of the nitty-gritty. So we knew that the game engine needed to keep track of the state of the game, and it needed to be able to register and validate teams and enforce the rules and keep everything dialed in and actually reliably sort of keep the game functional. So we took all of that and we sort of just had a conversation, the most informal design process I've ever been a part of. So we talked about the one-on-one feel and we said, well, that sort of feels like a bot interaction, a Slack bot interaction. We've done a lot of those. Let's do that. And we knew that we would need sort of an engine to drive all of this. And being a Go developer for going on 6 years now, Go was a natural choice for me. I knew it had the parallelism, the concurrency story down. I knew it would facilitate building out APIs very quickly and easily. I knew it would take a load, a beating in terms of traffic and interactions. And I knew it would do all that, using minimal resources and being very development friendly. So I basically out of the gate, that was the only way I was really thinking it would go. So Kevin and I knew we would be the only developers, so we kind of said, well, let's exploit this natural seam in this project. There's bots, and then there's sort of this engine platform idea. So Kevin's going to do one, I'm going to do the other. Okay, well, then we're going to have them interact. How are we going to do that? Well, we can use REST APIs. And then we sort of talked about the bots and the engine, the roles that they would play, how they would sort of interact, and how we would manage other aspects of the game. And the architecture that we sort of came up with these bots and this engine sort of scaled very well when we wanted to add more things like player management or team management or helping players along. It just became a matter of adding more bots, and it scaled beautifully, which is great. So in the end, we ended up with sort of a two-piece architecture. One was the game engine, and that ended up holding all of the sort of interaction logic. So anytime a player would guess at what a current flag was or ask for help or anything like that, that would be routed to the game engine, and the game engine would render, parse that response, see what it needed to respond back, and then render back a reply ultimately to the bot, which would ferry it on to Slack and to the player. Then the other piece of the architecture was the bots, and they would ferry the messages back and forth between the players and the handler, and they would facilitate any other sort of interactions and gamekeeping actions that we needed to have at the time. One key, very key, possibly the most key technical decision that we made early on was that Slack was going to be the only player interface to the game. And what that meant was that our game engine would be safely secluded in our virtual private cloud, and players would not be able to reach it. They would not be able to touch it. So that significantly reduced our overall threat surface, right? We could sort of stand on the shoulders of Slack and all of their abuse countermeasures and the reliability of their platform. And then our infrastructure would basically be shielded from a lot of that abuse just naturally, which was a huge productivity boon, if nothing else, for us. So here's a rough diagram of the final structure of our architecture. Like I said, it didn't start out this way. We started out with just the registration site, which we knew we needed to stand up so we could get some sense of how many players and teams we would have. And then we built the game engine, we built out the bots, and then ultimately on the morning of the game, we did this crazy manual migration because, as everyone here knows, when you're under an actual timeline, sometimes you can't automate all the things. You gotta do it manually sometimes to make it happen. So that's what we did. And we also stood up a leaderboard. And you can see here that the only public endpoints in our infrastructure were actually just the registration site and the leaderboard. The bots and everything else reached outward to Slack, so that, again, we provided sort of that buffer to our platform from players. So once we sort of decided on the architecture, Kevin and I started working in parallel. We wanted to be able to sort of work asynchronously and run with our parts. So we came up with an API contract. And we knew that there were general areas of the game that the engine and the bots would need to facilitate. We need to process and respond to player messages. We need to manage them. We need to manage the teams and the chat rooms that teams had. And then we would also need to actually provision players to those things. So we stood up basically a shared document. We documented sort of the API contract, what the calls would be, the routes, the expected arguments, and then we were free to basically run with our parts and come back together when we were at a ready state, and then we could put everything back together and merge it. One of the cool things that emerged from this was the hints aspect of the game. This is one of my favorite aspects of the game. So we wanted to be different than all the other capture the flag games that we'd experienced in the past, where if you get to a flag and you haven't seen that particular technology before, or you didn't have the know-how to capture that flag, you were basically stuck and the game was over for you. because you couldn't advance. We didn't want that. We wanted all of our players to be able to have fun, to be able to keep playing our game, to not just get like stuck on flag 2 and be done for the day. And so we actually introduced this concept of hints, which was so much more than hints. It was actually done with the goal in mind of player education. Like, players would actually learn while they were doing our game in real time. If they didn't know this certain technology that the flag mandated, the engine would recognize that they'd been there for a while, that they were struggling, that they hadn't gotten the right answer, that other teams were elapsing and eclipsing them. And then the game engine would start to feed escalating ever more specific hints to that team. Again, in the persona of the handler, creating this immersive, real, interactive feel that is truly tailored to the team and their progress at that moment. So we built out this hint infrastructure, this hint bot, and this hint module in the platform to make all this facilitated, so that if a team got stuck, they would be sort of helped along until they could progress.
Yeah, and one thing I want to add on to that is when we were doing our sort of post-game interviews with the players, I think every single question got a compliment on the hints that were given. So that was a really core ethos of design for us, was to give those hints. And, we essentially went and just did customer interviews to see how they went. And that was such a key component to the success of not only the game, but what the players felt at the end of it, that it was really awesome to know that we planned this whole thing without knowing if it was going to work or not. And then once we delivered it, it just landed perfectly.
So here's an actual screenshot of the routes and the route file in our actual code. We used a lot of standard library stuff. The Go standard library is outstanding, as everyone here knows. And then we used a couple of choice third-party packages, such as HTTP Router and Gorm, things like that. So we had these routes here, and then below, on the bottom half of this screen, we actually have a snapshot of the logs of the actual game being played. And you can see it was pretty chatty, but as we've alluded to several times, the Go runtime and our application handled it like a champ.
So as Alex and I, as he mentioned, when we were talking about developing the actual game, we were talking about facilitating this interaction. And something I was really inspired by was role-playing games, right? Everything from tabletop like Dungeons and Dragons to, The Witcher or Final Fantasy games, or even multi-user dungeons or MUDs, if anyone's ever played that. And we really wanted to drive this unique hands-on experience, and we thought that bots were the way to solve that. And it really turned out to be the case. Now, I'm a huge nerd for the Unix design philosophy of write code that does one thing and does that one thing really, really well. So we actually ended up having this collection of bots, which we refer to as regime at the very end of this. And every single one of those bots just did one thing, right? Checked hints. Okay, that's one bot. Check answers. That's one bot. Ban a player. That's one bot. So bots were completely critical to the way that we created this game engine. And we agonized for a really long time about what would happen if a bot died, and how was it going to get state back when it came back and started, performing its actions again. And we realized, well, we don't need to store state in the bots. We can store state in the game engine and just have the bots interacting with a core game engine that holds the sort of canonical state for the entire game. And that made it perfect. None of the bots died, fortunately, but if they did, and they, when we were doing sort of our chaos engineering testing and killing random things in the game, they were able to just come back seamlessly. So the player experience was never interrupted by a potential infrastructure failure.
So here's actually the mapping of the API contract and the API methods that we laid out to the actual bots that we ended up building out. And we ended up with 6 bots in total. And as we thought through the game and the bots and the platform that we wanted, we knew we were going to go with Slack this year, but we didn't know if maybe next year we'd want to play the game over SMS or over a web chat client or Telegram or something like that. So we had the foresight to make the platform agnostic to the actual interface or system that we were actually using. So instead of hard coding a bunch of Slack API calls, we built a platform interface. And then via dependency injection, we injected that into our bot base, which was just a generic bot container, which we tailored to each of the 6 bots that we ultimately ended up with. And so here's a quick snapshot of the platform interface code. It has the interface has a start and stop method in case you need to instantiate any real-time connections or anything like that. And then it has little collections of methods for each specific bot to use. So for the check answer bot, it has the capability to fetch, whatever the next player's message is on the platform buffer. And then it also has a capability to send messages back to the platform. So we can send back, whatever the handler had to say to the player on Slack, we can send it back to be output on Slack for the team to read. Then we have the team assignment bot, the player invite bot, and the player assignment bot, and some methods that are structured for those to use. Then we have the bot base. So the base, again, we have the ability to basically inject our platform adapter such that we can make it Slack today and Signal tomorrow. And then we also have a game config that we can put in there. And then an air handler function, which is just a little trick I saw somewhere that you can inject an air handler function from whatever application is running these bots, and then any bot errors can be routed and funneled wherever your application wants them to go, which makes management very easy. And then in the lower right of the screen, we have what's arguably the most important bot, the check answer bot. We have the start method for that bot. So this basically, the bot in turn calls the start method on the adapter, so that instantiates, in our case, the Slack real-time API connection. And then it basically loops over that channel, and anything that comes in on that connection channel, it will actually process. And so this is, again, in the check answer bot, this is the message process, or the process message function. And as we approached this, we knew this had to be production grade. This had to be resilient. So we have a lot of just really specific checks for the maximum length of the message and things like that to prevent abuse. And then as we go down here, we can actually see that once our platform receives a valid message, we actually send an acknowledgement back to the platform so that our handler says to the player, I see your message. Hold on one second while I check. And then we actually call the check answer method, which sends a API call to our platform to say, hey, platform, here's the team, here's the message they had. Is it the right message, or is it the right answer for this flag? And then our platform comes back to the bot with the response to that. And then the bot will ultimately render back to the platform, to Slack, whatever the engine said to render back, whether the answer was right, here's the next message, or the answer was wrong, try again. So then if we go to the other side of the house, we go over to the game engine side of the house now. We were on the bots, now we're on the game engine side. This is the actual endpoint handler for the check answer endpoint, the HTTP handler. So this, again, we have a lot of very specific checks. Is the team finished with the game? Is the team banned? Is the submitted answer blank, etc.? And finally, once we've gotten past all those validations, we actually do our function to see, is the guess that was submitted correct? We parse out the guess, and then we check it against the known answers. And if it isn't correct, we immediately render back a response to the bot. Yeah, this isn't correct. Tell the player, try again. And if the guess is correct, we actually do the bookkeeping. So we increment the team's current flag, we reset any flag timers, and then we actually persist that to the database and render back a correct answer message.
All right. So we spent all this time creating the core game engine and seeding all these data points and creating the story, and it sort of all culminated in the event that we ran at DEFCON, which was really cool. So this picture is from the day before, right? We were giving out custom badges, in this case, an Adafruit Circuit Playground. They were flashing some custom stuff on. There's the keyboard that I gave away is on here. We were just stuffing bags with swag that we were going to be giving out during the event. So, we were diligently working, the entire week before the event on getting, the physical aspects of the game ready, much less the months we had spent on getting the code set up, which was really, fun but stressful. Here's a picture of Blake and myself at the registration booth at DEFCON 26. You can see some people, expressing interest in the game. In the background there, you actually see a trailer that we had made. We contracted some students in art school to make us a trailer for the game, which was pretty cool. That's actually still online. If you go to the ICTF Twitter, you can view that. So feel free to do so. And yeah, and then we got people registered, got people excited, and we were getting ready to play the actual game. So the night before, we had a small gathering for some local hackers in Arizona, and it was about 11:09 p.m. specifically. I don't remember why I remember that time, but I do. And we realized we didn't have a scoreboard. We had pretty much everything else in the game set up, but we didn't have a scoreboard to display the state of the game. And that had been really critical in previous years that we were running ICTF, not only for spectator interest, but also if a team came up to us and said, Flag 6 is impossible, you cannot solve that, then I point to the board and say, well, 3 other teams have solved Flag 6. So we would argue that it is possible. It was really critical for the game to progress. So Alex, being the absolute champion that he is, put together a leaderboard for us that just looked beautiful. And this is an example of what that looks like. It's a little bit cluttered, but this is an actual screenshot from the game itself. So you get to see the teams and sort of their progress throughout the game. And we can see at the very end of it, Las Matildes took the day and they won the grand prize and came to our party and had a really great time. So it was really cool. So in the morning, we got up early, even though we probably only had like 3 or 4 hours of sleep, and we were getting ready to launch the game. We were doing some manual migration from the registration site to the production site. We hit some snags, but we were able to get that sorted out. The bigger problem that we had is we had 350-ish people waiting to be invited to our Slack instance that we were going to control the game from. And guess what? We got rate limited. That was an absolutely nightmare existential event for us, because if people couldn't get into the Slack, they couldn't play the game. Now, fortunately, we were able to reach out, do some back channels to, ask Slack, like, hey, can you help us out here? And they did. But we realized that, like, oh, that was a big thing we didn't consider. Maybe we should have had people pre-register into the Slack. And we actually experienced a game-breaking bug that was a result of my code at the very beginning. And there was a blocking condition we didn't account for. And I don't remember the exact details, but we wrote a patch and we got it deployed. And our last patch for the engine was actually 8 minutes after the game launched. So that was a big lesson for us, is to consider load testing. And this picture right here is actually me and Alex sitting at the counter in the suite we were staying in for this. And I'm there writing probably the best code of my life. I don't remember how I was able to do it, but that like 10 minutes of coding was probably the best I'll ever get. And you can see there, if you look in the background, some of the medicine or whatever you want to call it that we used to calm down later once the event was over. So once we got the initial conditions sort of sorted out, about noon, we were asking ourselves, like, how are we doing? What's the progress? And it was really cool to say that the engine was running fine. Like, we weren't having any infrastructure problems. But something that was really interesting that happened was we had submitted some code to GitHub. We'd committed code to GitHub, and we asked players to identify an email address related to a GitHub user. We used a couple different emails for the commit that we were doing, and there was one email that we were not expecting players to find. But there was actually a information disclosure vulnerability in GitHub that allowed players to find this Gmail address we didn't expect them to find. And the team who found it contacted us out of band and said, hey, this looks to be correct. Like, why is this flag wrong? And lo and behold, it was technically a correct answer that we didn't account for. So given the way that we created the engine, we were able to update the answers file and hot patch the game while it was going on without taking it down, without having to do any reboots or whatever. And then suddenly that was a valid answer, and some other teams got that as well once they got to that flag. So it was really cool to be able to hot patch in some things into the game that needed to be there. As Alex has talked about a couple times, this is a group of hackers. This is people who are going to come in and intentionally try to do bad stuff to our engine. So we implemented a lot of counter abuse measures, right? The first team to register for ICTF, their username was single quote or 1=1 semicolon dash dash, right? A very classic SQL injection payload. That's the kind of users we're dealing with here. So we had to make sure that we were very cognizant of the checking the inputs and outputs that we were giving to players, but also making sure that people couldn't abuse our engine. We had people that were just sending in mass amounts of data, which we weren't quite anticipating. And there may have been one or two flags that were given away, but ultimately we took that back and we improved our exploitation protections within the engine. And we only had to ban one team, but it was kind of cool banning one team because it meant that the abuse countermeasures that we had built in allowed us to just quickly one click, stop a team from being able to play and break the engine. That was really neat. So once we got towards the end of the day, we were able to focus on the players with our selection of Go as a technical component that was running absolutely flawlessly on top of this AWS architecture that we put together. We didn't have any technical issues. So when players started to get to that human intelligence portion that I talked about earlier with following people and getting bags and coats and things like that, we were able to, as a very small team, just pivot and coordinate and make sure that those people are having the best experience possible, which was really, really cool. This is actually a map that we gave to the volunteers for the game. We had about 20 volunteers on the floor of Caesar's Palace, coordinating, maybe being followed, sitting at a bar, giving messages. We also had game wardens, is what we called them, the people who were standing there just to make sure that nothing went wrong, that the players were safe, that the participants and volunteers were safe, which is great. So you can see here some of the paths that our players took that the volunteers were facilitating, which was very, very cool. And then when it came to the very end of the game, we actually only had one team complete the final flag, which is fair because the game, especially towards the end, given the cash prize, was fairly difficult. But even then, we gave out a ton of prizes. I think we gave out several hundred shirts, a bunch of stickers, like 100 badges. We had this crazy huge party. It was absolutely awesome. And when we set out to create this game, it became very all-consuming in our lives outside of our day jobs, right? This is not what we do for a living. This is the stuff that we do for fun. And I remember waking up that Sunday feeling like I had finally slept, which was kind of a fun experience for me to realize that I had lived and breathed ICTF for almost a year at this point, and to have the release of the game being over and being such a success was really incredible. And that is, due to not only the technology stack that we delivered, because Go is not only rock solid, but very comparatively easy to develop sophisticated and awesome solutions in, not only to the dedication of the core team, which Alex and Blake and myself were on, and the volunteers, but just everything just came together and it was amazing. And the release of Tension was almost equally as awesome as developing the whole game itself. So this is a picture. I get goosebumps when I look at this picture because this is the end of the event, and that's Blake and I manning the booth. Alex is there, but he's off screen, and we're giving out these prize bags, and there's this crowd with this energy, and it's absolutely incredible. And there's so many times when you have ideas about software that you want to create something, and the user experience that you're thinking about is abstracted, and it's cool to consider, but it's very theoretical. But to have worked with Alex, who I would consider one of my best friends, to create this software that really impacted people's lives was something I wouldn't trade the world for. And to see this crowd and to feel their energy made all those sleepless nights just totally worth it. And so if you're thinking about creating something like this, just do it and put yourself out there. We had no business creating the thing that we did, but it all came together. And with the exception of a couple small hitches, it worked beautifully. So thank you, Go, for facilitating that. And thank you, if anyone here happened to play it, thank you for playing our game. So with the postmortem, we'll leave this as an exercise to the reader to check out afterwards, because we know this will get posted up, but we will linger on the last slide just for a second for you to read, because we don't want to go over time here. I know we're taking a little while here. So thank you so much. Alex, can you go ahead and close this out, please?
Absolutely, yes. Thank you, everyone, for attending our talk, for attending the conference. It was awesome. Privileged to be here, as always. Again, I'm Alex Stockwell, co-presenter Kevin Tyers, and thank you. Enjoy the rest of the conference.
Thanks so much.